Okay, so let's apply this definition of a reference angle and the calculations that we've just done by taking a look at example number 1. In example 1, we're being asked to find the reference angle of 218 for part A. So 218 is going to terminate not in quadrant 2, right? Because in quadrant 2 is an angle that is between 180 or 90 and 180. But let me just draw a diagram so that we can get a better feel for what that looks like. Okay, so the original angle in standard form does have its initial side on the positive x-axis. And then terminal side, well, let's see, this would be 180, so it's past 180. Then in order to make it to 218 from 180, we would have to add 38 more degrees, right? So we're going to terminate somewhere in quadrant number 3. That's the terminal side. This whole angle is the original angle theta. Now to find the reference angle, let's remember the definition. The reference angle is going to lie between the terminal side and the x-axis, and it's going to form an acute angle. So here is the acute angle that gets formed between x-axis and terminal side. We'll call theta prime. Actually, just so that I stay consistent with these diagrams over here, the original angle is given in red. So I'll change the color of the original angle, and then the reference angle is given in blue. So I'll color code this red for the original angle. And then in blue, we'll have the reference angle, theta prime. All right, so if we're in quadrant number 3, how do we calculate? Well, you don't have to memorize those formulas that we just wrote. We can just derive them again just from looking at the diagram. If I take a look at this diagram, I see that 180 degrees, which is half of the cycle, plus the reference angle theta prime, so 180 degrees plus theta prime, is going to give me the full angle of 218 degrees. So think about it like this. This half cycle is 180, and then if we add theta prime, it gives us the full angle. So now I can solve for theta prime by subtracting away 180 from both sides. And we get 218 minus 180. If you punch that into your calculator or you do some mental math, we're going to get that that is going to be 38 degrees. And so that would be the reference angle. Now for example number 1b, that one is a little bit trickier because it's a large angle, which means we're going to be completing more than one cycle. In fact, we're going to be completing more than 2 cycles. Let's see what this one gives. Okay, so we have our initial side on the positive x-axis, and then that angle is going to rotate. Let's see how many times. Okay, 2 times 360 is 720, and 1387 is larger than 720, so we're going to continue. Let's try 360. 3 times 360 is 1080. 1380 is larger than 1080, so we're going to continue. 4 times 360 gives us 1444. 1444 is larger than the given angle. So what that means is that 1387 will complete 3 full cycles and then some additional number of degrees. Okay, so let me just write that on the side as side work. So 1387 is going to be 3 full cycles. That's 3 times 360 plus, let's see how many more we would be missing. So 1387 minus 3 times 360. So subtract away the 3 cycles. We would have to continue 307 degrees more in our diagram. Okay. So let's try it. This is 1 full cycle, 360, 2 full cycles, 720, 3 full cycles, 1080, and then 307 degrees is going to bring us to 1387. Okay, so then where is the reference angle? Well, it has to be between the terminal side and the x-axis, and it has to be acute. So that there is our reference angle, theta prime. Now, how do we find out what theta prime is going to be? Well, instead of considering the full 1387 degrees, I just want to consider this smaller piece. Let me color code that smaller piece. So I just want to consider this smaller piece, that smaller angle, and add it to theta prime, because whatever that angle is, when I add it to theta prime, it will give me 360. So this actually relates back to the smallest positive coterminal angle, right? What we see here highlighted in orange is the smallest positive coterminal angle. And what is the measure of that? Well, we found that measure when we took a look at how many additional degrees we had to rotate beyond the 3 cycles. That was 307 degrees. So 1387 degrees is coterminal. Yeah, so that one is coterminal to 307 degrees. And that's the measure that I'm going to use to find theta prime. I'm going to say if I take 307 degrees and I add it to theta prime, then I complete another cycle. If we take 307 degrees and we add it to theta prime, together they complete one cycle of 360. So to find theta prime, we simply subtract away 307. 360 degrees minus 307, that's going to give us 53 degrees. What I want to do now is I want to compare the reference angle versus a coterminal angle, because these two often get confused, and I want to make sure that there is a clear distinction between the two. So when we're talking about the reference angle, let's just list what the definition of reference angle is. It's going to be an acute angle and it does not need to be in standard form. The other thing is that it lies between the terminal side and the x-axis. And the x-axis, it could be the positive or it could be the negative x-axis. Let's think about a coterminal now. A coterminal angle can be acute, but it could also be obtuse, right? It's any angle that shares the terminal side with the original angle. Yeah, so this one could be acute or obtuse, or even right. We haven't seen that example yet, but later on we'll see one. A coterminal angle always has to be in standard form. That was part of the definition. I'm using form here, but I should really be saying position. I just interchange those sometimes. Okay, and then it lies between the terminal side and the positive x-axis always, because if it's in standard position, it always has to be between the positive x-axis and terminal side. Here's another difference. A coterminal angle can either be positive or negative. So it can have positive or negative measure. While a reference angle is defined to always be positive, to always have positive measure. So always has positive measure for the reference angle. I forgot to label what are these, to who these characteristics apply. These apply to the reference angle. These here apply to the coterminal angle. But they're clearly not the same, right? They have different characteristics. They're different types of angles. Okay, so now that we know what the reference angle is, let's go back to the original purpose, which is to find the trig functions of non-acute angles. Okay, so the trig functions of non-acute angles, we define the trig function of an obtuse angle to be the trig function of its reference angle. That is, we find the trig function by considering the right triangle that's associated with the reference angle. And then the sign of the trig function will be determined by the quadrant in which the reference angle lies. Okay, so let's see this through an example. For example 2, they want us to find the 6 trig functions of 210. And so what I'm going to do here is draw a diagram so that we can see what the reference angle is. So initial side on positive x-axis. And the angle is 210, which means that it's going to open past the 180 and it's going to go on to quadrant number 3. We'll have a terminal side here. The reference angle is going to lie between the terminal side and the x-axis, the part of the x-axis that makes the angle acute. So that would be the negative x-axis in this case. And so that's going to be our theta prime. Again, this red angle is the original 210 degrees. So then if we want to find the reference angle there, what we could do is say, well, 180 degrees plus the reference angle theta prime gives us a 210 degrees. So subtract 180 from both sides, and we're going to get that the reference angle is 30 degrees. So that's the first part. Now we're going to use that to find the 6 trig functions of the angle. So let me erase this here just to make room for this right triangle that I'm about to draw. And we know that this is now 30 degrees by our calculation here. So in a 30, 60, 90, which is clearly what this is, a 30, 60, 90. In a 30, 60, 90, the opposite side is always the smaller side, right? It's always the side x. Now, because I don't want to deal with variables such as x, and because I know that when I take the trig function, ultimately they simplify to the same value regardless of what the actual sides are, I'm just going to pretend that this is a 1 instead of an x. Okay. So opposite to 30 will have a 1. And then the hypotenuse is always twice that amount, so that's going to be 2. The adjacent side is always the smaller amount times radical 3, so that's just going to be square root of 3. And now this is where the second part of the definition comes into play. The sign of the trig function will be determined by the quadrant in which the reference angle lies. Well, what that simply means is that now we have to consider what is the direction of the x and what is the direction of the y. Okay, the hypotenuse is always positive, but these two are going to have a sign change. Okay, so let me just write this here. Hypotenuse is always considered positive. And the reason for that is that it's considered a distance from the origin. But the square root of 3, since it's going in the negative x direction, right? If we're going to the left of the origin, that's in the negative x direction. That's going to be considered a negative square root of 3. And then the 1, since we are going down, so down from the origin means negative y direction. So that's going to be a negative 1. And those are the values that we're going to use when we take a look at the trig functions. So sine of 210 degrees is going to be opposite over hypotenuse. Opposite to the reference angle is negative 1. Hypotenuse is 2. So we get negative 1/2. For cosine of 210 degrees, that's going to be adjacent. So that would be the negative radical 3 over the hypotenuse of 2. And remember, this is the adjacent side because it's touching the angle, but it's not the hypotenuse. Opposite side is directly in front of the angle. Okay. And then for tangent of 210 degrees, that is going to be opposite, which is negative 1, over adjacent, which is negative radical 3. So negative 1 over negative radical 3. And so the negatives cancel out. We end up with a positive. The other thing too is that we want to rationalize. So I'm going to multiply top and bottom by a square root of 3. We're going to end up with an angle, with a measure of square root of 3 over 3. Now cosecant 210, we can simply take the reciprocals of these values. That would be a negative 2 over 1, which is negative 2. For secant of 210, take the reciprocal of cosine, which is going to be this negative 2 over square root of 3, and just make sure to rationalize. So multiply by square root of 3 over square root of 3, and that gives us a negative 2 radical 3 over 3. And finally, the last one, cotangent. of 210 degrees. Take the reciprocal. We won't take the reciprocal of square root of 3 over 3 because that's going to give me some work in rationalizing. Instead, I'm going to take the reciprocal of this unrationalized answer. So we're going to have a negative radical 3 over negative 1, which is simply going to become a radical 3. And so that would be our final answer, or answers for that problem. And I'll zoom out a little bit so we can see the full diagram. Let's try example 3. For this one, we're finding the trig function of, we're evaluating cosine of negative 240. So first I want to draw where is negative 240 so I can figure out what is the reference angle and take it from there. Okay, so here's x and y. Initial side is on the positive x-axis. To determine the terminal side, this is negative, so we open clockwise. This here would be negative 180, which means we have to continue, but not all the way to the y-axis, because that would be negative 270. Right, so we stop somewhere in quadrant number 2. So this is our negative 240 degrees. Now to find the reference angle is supposed to be between terminal side and the x-axis, the part of the x-axis that makes the angle acute. So it's going to be between terminal side and the negative x-axis. That's how we obtain an acute angle. So this here would be our theta prime. Now, in order to obtain the reference angle there, we're going to have to figure it out from the diagram, because the formulas that we found in the first 2 pages, those only concern to positive angles, right? Angles that rotate counterclockwise. So in this one, we're going to take a look at the diagram and consider, well, if we go up to here, we would get a negative 180, right? And then if we take the theta prime and subtract it from if we take the 180 and we add it to the negative 240, that's how we would get the theta prime, right? Because this part, so basically what I'm saying is theta prime plus negative 180 degrees gives us the negative 240 degrees. Okay, so theta prime, if we add now the 180 to both sides, we'll get negative 240 plus 180, which means that theta prime would be a negative 60. Now the only problem here is that we've defined the reference angle to always be a positive, an angle with positive measure. So we're going to drop the negative and simply have 60 degrees. So I'll write that comment here, because reference angles have positive measure. Okay, so we have a reference angle now, which means we can use it to draw a right triangle. I'll go ahead and erase this so we have some room. This is 60, and this is 90, which forces this top one to be 30. Now in a 30, 60, 90, opposite to the angle 30, we always have the smallest side, which we're saying just let it be 1 because we don't want to deal with the variable x. Okay, so we'll just let it be 1. The hypotenuse is always twice that amount. The adjacent side is always, or sorry, not the adjacent side, the side opposite to 60 is always 1 times radical 3, or simply radical 3. And now we have to consider the signs of those sides. So hypotenuse is always considered positive. For this adjacent side to 60, it's going in the negative x-axis, so that would be a -1. For square root of 3, that's going up in the positive y-axis, so that's going to remain positive. And so now if we want to find cosine of -240, which I'll do here on the side, cosine of -240 degrees, that is going to be the adjacent side, which is -1, over the hypotenuse, which is 2. So we're going to have a -1/2 as a final answer. And one more part to this example 3, and that is to find cosine of 780. So again, let's go through the steps. First part, let's draw the diagram. Initial side on the positive x-axis. Terminal side, well, let's see, we're going to have to complete 2 full cycles because 2 full cycles is 720, and that's smaller than 780. So this is 360. Complete a second one, that's 720. And then in order to make it to 780, we would need to complete 60 more. So just so that we know, I'll write it down here. 780 is 2 full cycles plus 60 more. You can verify on your calculator. So this is going to be 720. Okay. Plus 60 more would bring us more or less somewhere there. So now to find the reference angle. Reference angle will be between terminal side and the side of the x-axis that makes an acute angle. So that would be down here. So that's going to be our reference angle. Now, how much further did we have to complete beyond the 2 cycles to make it to the terminal side? Because that's going to give us the measure of that angle. Well, that's actually 60 degrees, right? We saw from this calculation. So we have a reference angle of 60 degrees, and just because it seems pretty busy there already, I'll redraw that angle over on the side. This is 60 degrees. Now, based on that reference angle, we're going to draw a right triangle, which means we'll drop down that vertical side. We'll have a 90 degree there, and that'll force the top angle to be 30 degrees. Opposite to 30, we'll have 1. Opposite to 60, we'll have radical 3, and hypotenuse will be twice the smaller side, so that'll be 2. Now, this is the positive x-axis. Over here, we would have the positive y-axis. I'm simply redrawing the diagram so that it has the right triangle by itself. So what does that mean for the signs of these side measures? Well, 1 is going in the positive x-axis. Square root of 3 is going in the positive y-axis. So we don't need to change the signs for those. Those are fine as they are. Cosine of 780. We can now read from the diagram. Cosine will be adjacent which is 1, over hypotenuse, which is 2. So our final answer would be 1/2. Oh, and we actually have two more of these examples. So part C, tangent of 675. Let's try diagram. Okay, so 675, how many full cycles is that going to give us? Well, it's just going to give us one full cycle. Reason being, 675 is going to be 1 times 360, one full cycle. And then we can have 675 minus 360 to see how many degrees are left over. That would be 315. Okay, so since we're going to terminate in quadrant number 4, let me just rewrite these up here so I have some space. So it's 1 times 360 plus 315. Right, so what that means is one full cycle, that's 360, and then we go around to 315, so that we terminate in quadrant number 4. So how does that work with the reference angle? Well, we have, it needs to be between the terminal side, which I forgot to highlight, so let me just highlight that real quick. It has to be between terminal side and the x-axis that makes it acute. So that would be there. Here we have this reference angle, theta prime. In order to find what theta prime is going to be, well, I can simply take this portion, the smallest positive coterminal angle to 675, which we know is 315 from this earlier calculation that we made. Okay, so 675 and 315 are coterminal. And now, if I take that 315 and add it to the reference angle, it should complete one of the cycles, 360. So we're able to solve for theta prime in that way. That gives us 45. Okay, so now I'll draw right triangle. Knowing that this is now 45 degrees, it might actually help to redraw that same diagram by itself, focusing on quadrant number 4. So this is x, and this is going to be y, but it's the negative part of y, so y would continue that way. And now we have a triangle, right triangle, where this side is 45 degrees. Now in a 45, 45, 90, because that's what this is, the two sides measure the same. So if this measures 1, this also has to measure 1. And the hypotenuse measures the x radical 2. So if this is x, then the square root of 2, or hypotenuse would just be square root of 2. Now for the signs of the sides, this adjacent side is going in the positive x-axis, so it remains positive. This opposite side is going in the negative y-axis, so we need to add a negative to that. And now we're ready to find tangent. Tangent of 675 degrees is going to be opposite to the reference angle, so that would be -1, over adjacent to the reference angle, so that would be 1. So we're going to get -1. finally, part D, cotangent of negative 405. And 405 is going to complete one cycle in the clockwise direction. Let's go ahead and draw that first. Okay, so negative 405, that opens clockwise. Ones would be negative 360, and actually let me switch colors since we are drawing the original angle and not the reference angle. So that would be negative 360. We're not going to be completing the second cycle because two cycles would be negative 720, right? So we know that it's going to be more than one cycle, but less than two. And to figure out exactly how many more degrees beyond the 360, what we could do is we could take negative 405, and we've already completed negative one cycle, so negative 1 times 360. And then we want to know how many extra more we need to traverse. So this is unknown. I'm simply going to write here maybe a variable for now. Let's call it n. Okay. And then negative 1 times 360 would be a negative 360. So we have negative 405 degrees is negative 360 plus n. Add 360 to both sides. And we're going to get that n will be 45 degrees. And it'll be negative 45 degrees. So what that means is that we're still continuing in this clockwise direction, 45 degrees. Okay. But by the work that we just completed, we actually have a pretty good idea of what our reference angle is going to be. Reference angle is, again, between the terminal side and the part of the x-axis that forms an acute angle. So that would be this here. That means that we have a reference angle of 45 degrees. Because we had to rotate that additional negative 45 degrees to make it to negative 405. Great. So with that in mind, we'll be drawing a right triangle in quadrant number 4. So I'm just redrawing this on the side so it's a little easier for us to read. So this here would be the the y-axis. We have 45 degrees here, and this is a right triangle. Now, in a 45, 45, 90, we mentioned earlier, this could be 1. This would have to be negative 1 because we're going in the negative y-axis. And then the hypotenuse would be radical 2, and hypotenuse is always positive. So what we're obtaining here is exactly the same diagram that we had for tangent of 675. Now, cotangent of negative 405 degrees, if tangent is opposite over adjacent, cotangent would be adjacent over opposite. So that would be a 1 over negative 1, which is still a negative 1. All right, welcome everyone to Math 40. Can you guys see the doc cam and hear my voice okay?
Yes.
Okay, great. Thank you so much. So we are going to start lecture notes week 3, but before we do, I hope you guys have had an opportunity to take a look at the lecture video for Monday. Do you have any questions from that lecture video that you would like me to address before we start on week 3? If you think of any questions along the way, feel free to, just interject and let me know. The video is found under Unit 1 in the modules, the Canvas modules, so you should be able to see it there under Monday, September the 14th. Okay, but today's lecture will focus on week 3, and it's going to require that you know some of the concepts from Monday's video. So if you haven't had a chance to do that yet, I encourage you to watch it maybe after this lecture, or is maybe tomorrow, early tomorrow, while this material is still fresh. Okay, so lecture notes week 3 deals with an alternative definition to the trig functions. In this alternative definition, we're going to be considering a point on the terminal side, which we're going to just generally call x comma y. And so we're going to pretend that point is on there, and this here is my terminal side. And of course, the initial side, because we have these angles in standard position, needs to be on the positive x-axis. And I realize the image is a little bit dark. Let me see if I can try to make it any brighter. Oh, that seems to work. There we go. Okay, is that better? A little bit?
Yeah, much better.
Much better? Okay, great. All right, so based on that point, let's just go ahead and draw the right triangle that we normally draw with the angle theta. This would be the opposite side, this would be the adjacent side, and this is the hypotenuse. Well, now that we have this point x comma y, in order to get to that point, or in order to plot it, we would have to move to the right x number of units. Right, so this distance down here, the adjacent side, is actually x. And then in order to make it up to the point x comma y again, we would need to go up y number of units. So that means that this distance here is y, the opposite side is y. And then the hypotenuse we're able to find out because this is a right triangle, so we can apply Pythagorean theorem. And Pythagorean theorem tells us that the sides of the two legs squared, the sum of them, gives you the hypotenuse squared. So what I'm going to do here is, so that I don't have to write hypotenuse all the time, I'm going to label this r. Okay, and then to find r, we would simply do r squared is equal to x squared plus y squared. And that means that r would be the square root of x squared plus y squared. Now we only consider the positive root, even though we essentially took the square root of both sides to come up with the final answer, but we only take the positive because we consider the hypotenuse to be a distance from the origin. Yeah. So now with that, with those labels, let's think back to the trig functions. If we wanted to define or take a look at what is sine of the angle theta, under the very first definition that we learned, we said sine was opposite over hypotenuse, right? Well, now the opposite side is y, right? So we get y over r for the hypotenuse. Now for for cosine theta was adjacent over hypotenuse, but adjacent is now this x. So we get x over r. And finally for tangent was opposite over adjacent, so we get y over x. So questions there in regards to how we're tying it back to this point, x. And I'll go ahead and color code these x and y's. So x is this adjacent side, and I'll have orange for the opposite side, which is y. Okay. So basically this distance here is y. Well, let's see if what we found here for the trig function definitions also holds for an angle that terminates in quadrant number 2. So an angle that terminates in quadrant number 2 would look more or less like this. And from Monday's lecture, we found out that if we want to find the trig functions of an angle that is in quadrant number 2, we have to consider the reference angle. The reference angle in this case, do you guys know where, or do you guys remember where it would be found?
Is it in between the, I forgot what it's called, but it's in between the x-axis and I forgot the other one.
The terminal side?
Yeah.
Yeah, exactly, good. So here's our terminal side. And then we want an acute angle that gets formed with the x-axis, so that would be this side here. So I'll just color code that green. This is called the reference angle. And in the previous video, we called the reference angle theta prime. And so now with that drawing, we create a right triangle that involves that reference angle, and we consider the adjacent and opposite sides relative to this smaller angle. So relative to this smaller one, this would be the adjacent side, this one would be the opposite side, and this would be the hypotenuse. But again, because this terminal side is passing through a specific point, and actually let me go over this with blue, because we use blue for X over here. It looks a little messy, but that's supposed to be blue. Now that we have these labeled, we can take a look in reference to this point X. In order to plot this point, we would have to move X units to the right. So that means that this adjacent side is actually X. And then to make it up to the point, finally, we would need to go up Y units in the Y direction. So that would be this here. And so again, we try to find what the trig functions are going to be in this case. Well, sine theta would be opposite over hypotenuse, but opposite, and I forgot to label this here, this should be Y. So the opposite is still Y. And then the hypotenuse, earlier we labeled it as R. The terminal side we label as R. So we're going to do the same thing here. So opposite over hypotenuse would be Y over R. And we get the same definition that we got earlier for angles that terminate in quadrant 1. The same thing is going to happen if we look at cosine. Cosine theta would be adjacent, which is X, over hypotenuse, which is R. And finally, tangent of angle theta is opposite, which is Y, over adjacent, which is X. So we're starting to maybe have the suspicion that this could potentially work for every quadrant. And what's actually nice about this as well is that if you remember again from Monday's video, we said the trig functions are going to have different signs, like meaning now they can potentially be negative depending on the quadrant. In quadrant number 2, do you guys remember which trig function turned out to be negative?
The X is negative.
The X is negative, good. So any trig function that involves the X will be negative. So that would be cosine and tangent, right? Good. And that's automatically going to come from looking at the point. Okay, so we have 2 more quadrants that we want to verify. Let's take a look at an angle that terminates in quadrant 3. In this case, again, this is the terminal side here. Where would the reference angle be found? Between terminal side and which axis?
X-axis.
Good, the x-axis, and in particular, it's going to be this negative side of the x-axis. So we're going to see the reference angle form here. That'll be theta prime. Again, we draw a right triangle. And then the opposite side is this side that's going down in the y direction. The adjacent side would be here on the x-axis, and then the hypotenuse is this terminal side. Now focusing in terms of y and x, adjacent side is going to be the x, right? Because we move to the left x number of units. Then we move down in the negative y direction. So that's also given by that y number there. And finally, the hypotenuse is just r. where r we compute according to this Pythagorean theorem. So adjacent is x, opposite is y. If I try to find sine of the angle, sine is going to be opposite over hypotenuse. That's y over r, so it's consistent. If I try to find cosine, that's going to be adjacent over hypotenuse, so that would be x over r, and that's already what we have. And same for tan. Tangent is going to be opposite over adjacent, so that's a y over x. And one more that we'll verify, that's in quadrant number 4. By the way, if you have any questions at any point, please stop me. Yeah, but now looking at quadrant number 4, here is our terminal side. And reference angle will be between the terminal side and which part of the x-axis? Well, if we want this angle to be acute, positive, good, yeah. If we want it to be acute, it's going to be between the positive x-axis. Oh gosh, I used the wrong color again. But in any case, between the positive x-axis and the terminal side, this is where we'll have our reference angle. Then draw the triangle. This is the opposite side. This is adjacent. Adjacent still corresponds to the x direction. Opposite side, since it's going vertical, still corresponds to the y direction. And the hypotenuse we're going to continue calling r. So with those definitions in mind, we still get sine of angle theta will be opposite, which is y, over hypotenuse, which is r. Cosine will be adjacent, which is x, over hypotenuse, which is r. So that's this. And tangent is opposite, which is y, over adjacent, which is x. So we still get the same thing. So regardless, the moral of the story is regardless of which quadrant your angle terminates in, if you can find a point on the terminal side, the trig functions are going to be given by these 3 formulas. Sine is y over r, cosine is x over r, and tangent will be y over x. Do you guys have questions?
I have a question.
Yeah.
So I know you just went over it, but I just want to know if you could like re-clarify, like how exactly do you determine which setup to use for each quadrant?
You mean like where to draw the triangle?
Yeah, and then like, yeah.
Yeah. Okay, so we draw the triangle always between the terminal side and the side of the x-axis that will form an acute angle. So it always has to be connected back to the x-axis. So here that's that's kind of like the only option that we have. Well, the other option that we have would be to draw it here, but that would not give us a right triangle, right? So we're going to be drawing a right triangle here. Then if you take a look at the second quadrant, here's the terminal side, here's the x-axis. We're going to be drawing, since it needs to touch the x-axis, we're going to be drawing it here in the negative x-axis to form the right triangle.
Okay, so the point ends up, okay, so the angle's going towards the x and the y all the time, right? Wherever it's at on the circle.
So the angle is always touching the x-axis. Yeah.
Oh, okay.
So just be careful because it's actually a very common mistake to want to draw the triangle sometimes here. Like I've seen drawings that have the triangle there. And so that would be incorrect because, well, it doesn't involve the reference angle anymore. And so, and it doesn't touch the x-axis. So you have to remember that it's always, one of the legs will always be on the x-axis and it's always going to involve the terminal side.
Oh, okay. Thank you.
Yep, no problem.
I also have a question.
Yeah.
are we just watching you do this, or are we doing this ourselves too?
I think it would be most beneficial if you guys go right along with me. That way, you know, that way you fill out the notes, and if you have any questions, you can jot them down as well.
Okay, thank you.
Yeah, no problem. Okay, so let's move on to the next page. Is that okay? Any further questions?
Is this going to relate to the all students take calculus?
Yes, it will. In fact, that's a very good observation. If you think about all students take calculus, that's telling us which trig functions are positive in which quadrants. So in the first quadrant, all of the trig functions are positive, right? And then if you look at the x and y coordinates of the point, it lets you know why. Reason being is that the x is in the positive direction, the y is in the positive direction. So if you try to take any type of ratio between x and y and the hypotenuse, by the way, the hypotenuse we said was always positive because that's a distance, then we're going to end up with only positive results. If you compare that with quadrant number 2, though, in quadrant number 2, one of these two is negative, right? Which one's negative in quadrant 2? What
Would it be the
type?
y?
Well, the y is actually going up to the positive, right? Like if, well, the x, yeah. So the x is negative and the y is positive, right? Because the negative goes to the left of the zero mark. So to the left is considered to be negative. And then y is going up, and that's considered to be positive. We find like all the positive numbers above the zero mark there. And so these points, anything in this quadrant, x will be negative and y will be positive. So then when we take a look at the trig functions, the sine is y, which is positive, over r, which is positive, so sine will be positive. But then cosine is x over r, x is negative, so this will be negative over r, which is positive. So we're going to end up with a negative over positive, which is negative. So here cosine will be negative. And then same for tangent. Tangent is y over x. Y is negative. X is positive. So we end up with negative over positive, which is going to be negative overall. So the only trig function that is positive in quadrant 2 is sine, and that corresponds to the students, right? All, and then students. And then this one, what was this one? Do you guys remember? This one was
tangent.
This one's tangent. Yep. And so it was representing tangent. So in this quadrant, only tangent is going to be positive out of the 3 trig functions, sine, cosine, tan. But yeah, good observation. Does relate back. In fact, we're going to see it with this next example as well. And hopefully, I know that when we're just using letters, it's a little obscure because everything is so abstract. But I did want to give you some background in regards to the formulas. Okay? And then we'll see it with some numbers in example number 1. Okay, so let me just bring over the definitions that we had in the first page, the ones that we derived over here. So sine was y over r, cosine was x over r, and tangent was y over x. Now cosecant is the reciprocal of sine. So what is cosecant going to be?
R over y.
Good, yep, r over y, good. What about secant?
R over X.
Mm-hmm, good. And finally cotangent, what's that going to be?
X over y.
X over y, awesome, yep. And just as a note to help us remember, r will always be calculated as x squared plus y squared, because that is the hypotenuse of a right triangle where the legs are x and y. Okay, so let's see it with some numbers now. Example 1 reads, the terminal side of an angle theta in standard position passes through the point -3, -4. Find the values of the 6 trigonometric functions of angle theta. So I'm going to draw a diagram, even though technically these definitions or these formulas that we found don't really require us that we draw a diagram, because we could just replace what y and x are in. In fact, let's do that first. Let's simply replace them into the formula, and after we've done that, we'll verify that our answers are correct by drawing the diagram and seeing it from the picture. Okay, so just by using these formulas, to have sine, I'll need y, which they gave me, and I'll use the same colors that we were using on page 1. So we had blue for y, and I'll need r as well. I don't have r yet because I need to compute it, so let's take care of that now. R is going to be the square root of x, which is -3 squared, plus y, which is -4 squared. And that becomes the square root of 9 plus 16. So that is the square root of 25. And the square root of 25, well, that's 5. Right, so we have r equals 5. And now based on that, we can say, well, sine of angle theta is going to be y over r from the formula that we found. Y is -4 and r is 5. So we just computed that. Okay, next trig function would be cosine. For cosine of angle theta, we have x over r from the formula. X is now -3. And so -3 over r, which is 5. All right, let's look at tan. Tan theta will be y over x, and y is -4, x is -3. What happens when we have negative over negative?
Becomes a positive.
Yeah, it becomes a positive. Good. So this is going to become a 4 over 3. And now we can use the formulas to help us find cosecant, secant, cotangent, or we can simply use the fact that they are reciprocals of the first 3 functions that we just found. So for instance, for cosecant, all I have to do is flip the -4 and the 5 to get 5 over -4. For secant theta, I just need to flip the -3 and the 5 to get 5 over -3. And then for cotangent, I just flip what we have for tangent, which is this 4 over 3, to get a 3 over 4. Right, so we have that. So any questions with using those formulas? Right, now I said we want to verify with the picture. Let's connect it back to the original definition that we learned. The opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So I'll draw the diagram down here. It looks a little crooked. Let's see. Is it really bad? Oh, it's not that bad. Okay. Okay, so we have x, y, and I'll make this -4 then -2. Over on the side, that's approximately +4, and then 2. And then we can draw the other tick marks in between. Okay, so this will be +4 and this will be -4. Right, so the point that they gave us that is on the terminal side is this -3, -4. So -3 would be in the x direction, and then -4 would be in the y direction, which means we have the point about there. So that would be our terminal side then. Initial side is always on the positive x-axis because we do draw it in standard form. But this here would be our terminal side, which means this whole thing would be the unknown angle theta. They don't tell us what it is, except this is -3, -4. Okay, now from Monday's lecture, if we want to find the trig functions of this angle theta, we would need to have the reference angle. The reference angle will be between terminal side and which part of the x-axis? Terminal side and the negative x-axis. Okay, so that means we have a reference angle here. Now to draw a right triangle with that angle there, I'll erase the -2 for now so that it doesn't get too cluttered. Okay, this is my right triangle. I know what this side is, right? I know the point is -3, -4. So that means that in this direction we move -3. And that also happens to be the adjacent side. So the adjacent side is -3. Now this side that's vertical is my opposite side. And I also know what it measures along with the direction. It's going to be -4 because we went down 4 units to make it to that point. And so we have -3, -4 for opposite and adjacent sides. The hypotenuse of this triangle we can find by applying Pythagorean theorem. In fact, we did that earlier and we got an R of 5, so this measures 5. Now, based on this diagram, if we try to find sine, cosine, tangent, sine would be opposite, which is -4, over hypotenuse, which is 5. And that's exactly the same thing that we got from applying the formula. If we want to find cosine, it would be adjacent, which is -3, over hypotenuse, which is 5. And again, that's the same exact thing that we got simply by applying x over r. And finally, for tangent, that would be opposite over adjacent, which is -4 over -3. And that is exactly the same thing that we got simply by taking a look at the coordinates of the point. And so it's a lot quicker in that, or thinking about the trig functions with these definitions, it's a lot quicker to find what they are because you don't have to draw the picture. You just have to see what is x, what's y, compute this r, and plug in. Is that okay? Do you guys have questions? Okay. Now I want us to try one more. In fact, if you have an extra sheet of paper, go ahead and bring it out. I want to give you guys a problem for extra practice. So I'll just label this extra practice. So just Try to find the 6 trig functions for an angle that has this point on its terminal side. So find the 6 trigonometric functions of angle theta if the terminal side passes through the point, let's say -12, 5. And then once you have found those, once you have found the trig functions, verify that your answer is correct by drawing a diagram. Okay, so I'll just write that here. Verify your answers by drawing a diagram. Okay, so I'm testing audio at this moment. Are you guys able to hear okay?
Yeah.
Yeah, okay, so let's see. All right, so just take about 5 minutes to try this problem, and then we're going to come together and complete it together to verify that your answers are correct. Okay, so let's see, let me ask you guys, what did you get for R?
13.
13, okay, good, yeah, so it should be 13 in here. Let's go through the work. We're gonna get R is equal to the square root of negative 12 squared plus 5 squared. So that'll become the square root of 144 plus 25. Then that becomes the square root of 169. And finally, the square root of 169 is 13. Okay, what about for sine of theta? What do you guys get for sine theta?
5/13.
Good. How about cosine?
12/13.
Good, well, very close. So we want to make sure that we include that negative. So yep, negative 12/13. How about tangent?
Negative 5/12.
Good, negative 5/12, awesome. And cosecant becomes what?
13/5.
Mm-hmm. Awesome, yep, we're flipping the 5/13, and that's how we get the 13/5. Then secant, we're going to flip the negative 12/13 to get negative 13/12. And then finally for cotangent, we flip the negative 5/12 to get negative 12/5. Okay. Do you guys agree with this? Have any questions on it? All right, let's verify the answers by drawing a diagram. Let's see if it agrees with the first definition that we learned for the trig functions. Now, for this diagram, I am plotting the point negative 12, 5. So I need to make sure that I have enough room on the left-hand side of the y-axis to plot negative 12. So I'm going to draw a somewhat longer line. All right, let's see. How many squares do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, that's going to be a very large picture. How about I just go up in increments of 2? So what I mean by that is that'll be a 2. This is 4, 6, 8, 10, 12. That's probably easier. And it'll be negative, of course. So let me not forget about my negatives. Okay, so negative 10, negative 8, and negative 6. Same thing going in the y direction, so I'll have 2, 4, 6. And we can also label the negative y-axis and the positive x-axis, but since my focus is going to be mostly in quadrant number 2, given that I'm plotting negative 12, 5, I won't worry too much about labeling those. I will, though, draw the initial side on the positive x-axis. I'll plot the point negative 12, 5. So negative 12, and then 5 would be halfway between 4 and 6. And that means that our terminal side has to pass through that point. And that means that this here is our angle theta, and I'll label the point. This is negative 12, 5. Now, based on this diagram, reference angle is where? Between terminal side and which side of the x-axis?
Negative.
Good. Yep, the negative x-axis. So here, that the angle that gets formed by this blue line on the terminal side is going to be our reference angle theta prime, which means we're drawing a right triangle that looks like this, where this is the opposite side. This is the adjacent side. and hypotenuse is this r, which we've already found to be 13. So I'm just going to label it right away. Okay, that's the hypotenuse. Okay, so what would be the adjacent side here? What would be the measure and the direction of it? What is this measure here?
-12.
-12, excellent. Yep, -12. So that would be the adjacent side. And then what would the opposite side be? What is this here?
5.
5, good. And that information we're getting from the coordinates of this point, right? We plotted the point, and now that we've plotted it, we can see what these measure from those two values. All right, so now that we have this diagram, if we wanted to go and use definition 1 of the trig functions, where we have opposite over hypotenuse for sine, well, that means that sine would be 5/13, which is the same thing that we got without the diagram by using y/r. If we double check cosine, cosine would be the adjacent, which is -12, over hypotenuse, which is 13. Here it is for cosine. And finally, for tangent, it would be opposite, which is 5, over adjacent, which is -12. So we do get -5/12. And then the rest would just be the same because we're flipping the same numbers. So it all agrees. We're good. Okay. You guys have any questions? Would you like to see another extra practice, or we're good to continue with the next page?
Could you do another practice just so I
Yeah.
can have it done?
Yeah, of course. Yeah, let's do another one. I'll bring in a different sheet. Let me this here. And we'll say this is also extra practice. The same directions as before. We're going to be finding the 6 trig functions. What did I write? Trigonometric. There we go. Functions of angle theta given this point. So if the terminal side passes through the point, let's choose something that perhaps might not simplify as nicely when we take the radical. Let's just try, how about 1 and -2? So 1 and -2, and then we're going to verify our answers by drawing a diagram. Okay. So again, I'll let you guys work for maybe about 5 minutes or so, and then we'll come together and we'll work on it together to make sure that we agree on our answers.
Professor, we couldn't hear you. I think you forget to unmute it.
Oh, thank you. Yeah, I haven't spoken yet. I'm just kind of writing down, prepping for your answers. Yeah. Yeah. And by the way, do we have any suggestions for R? What do you guys get for R?
Is it 5?
Square root of 5.
Square root of 5.
Square root of
Okay,
5.
good. All right, so let's just show the work to make sure we're all on the same page. We get this by taking the square root of x squared, which is 1, plus y squared, which is negative 2. So that becomes a square root of 1 plus 4, and that is finally the square root of 5. And square root of 5, we can't simplify any further, so we keep it that way. Now, for sine of theta, what did you guys get?
Negative 2 over 5.
Okay, so yeah, very close. So negative 2 over radical 5, because it is y, which is this negative 2 over r, which is the radical 5. Excuse me. And we can't leave our answer that way. Usually I'm gonna leave it like that for now, but just recall that if you have a radical in the denominator, that you always have to try and rationalize it. Yeah, but just because it's gonna make it easier for us to verify when we have the diagram, I'll leave it like that for now. Then any suggestions for cosine theta?
1 over radical 5.
Good, 1 over radical 5. What about tangent?
Negative 2 over 1, which is negative 2.
Excellent. Yep. Negative 2 over 1, which is negative 2. Yep. What about cosecant?
Radical 5 over 2.
Good. Yeah. So radical 5 over 2. And let's not forget about the negative, right? Because we did have that negative 2 over radical 5. How about secant?
Radical 5 over 1.
Radical 5 over 1. Yep. And that'll simplify to a radical 5. And finally, for tangent, what do we get?
Negative 1 over 2.
Negative 1 over 2. Good. So negative 1/2. Awesome. Oh, sorry. I wrote tangent again. I meant cotangent. Thank you. No wonder people were quiet. Yeah, so it's cotangent. Let's draw the diagram to verify that it's going to agree with the first definition that, that we learned. So in this case, we'll have a 1 and negative 2. So that would be focus on which quadrant?
2.
Well, not quite, because
Fourth quadrant.
fourth quadrant, yeah, our fourth quadrant because the x is positive, so we will be moving to the right, and then the y is negative, so we'll be going down after that. Okay.
I have a question real quick. Did you, I missed it. Did you say for sine and cosine, we do have to simplify it so that it's like negative 2, radical 5 over 5?
Yes, we do. The reason why I'm leaving it like this for now is because when I draw the diagram, it'll just make it quicker for us to kind of verify. But after that, we'll go in and we'll rationalize the denominator.
Okay, thank you.
Yep, no problem. Okay, so I'm going to make this 1, this 2, and then this is negative 1 and negative 2. Now we have the point 1 comma negative 2, which would be down here. So then initial side will be on positive x-axis, and I haven't labeled that, so let me just label that real quick. So it'll be on positive x-axis, and then terminal side has to pass through that point. Oops. So there's our terminal side. And that is 1 comma negative 2. Now we have to draw a reference angle because this is not acute. It's something that is obtuse. It terminates in quadrant number 4. So where is the reference angle between terminal side and which part of the x-axis?
Positive.
The positive, yeah. So even though this is also between terminal side and positive x-axis, but we're actually considering this angle here, right? The acute angle in here. So that would be our theta prime. And that didn't quite show up. Let's try that again. Theta prime. Okay. So now we'll draw the right triangle based on that side there, and I'll just relabel the one above the x-axis so that we can see the triangle clearly. Now, opposite side would be this vertical leg that we just drew. And by the way, what is the measure of that opposite side?
-2.
-2, good. And we're taking that from the y coordinate, right? Since it goes down, -2. Then the adjacent side would be here along the x-axis. And what would be the measure of the adjacent side?
1.
1, good. Okay, so the adjacent side is 1. And then hypotenuse we found by applying Pythagorean theorem. That was square root of 5. Okay, so now to verify, sine would be opposite, which is -2 over hypotenuse, and that's square root of 5, and that's exactly what we have. Cosine would be adjacent, which is a 1, over square root of 5, that's exactly what we have. And then tangent would be opposite, which is -2 over 1, over adjacent, which is 1. So we get -2 over 1, and that gives us -2. Okay, so these first 3 agree, which means that these last 3 are also going to agree because we just flipped sine, cosine, tangent to get these last 3. Okay, so it's agreeing with our diagram, which means we've done it correctly. Okay, more than likely have done it correctly. So questions up to that point?
No.
Okay, good. All right, so now we're going to rationalize because we don't like to leave radicals in the denominator. We're going to multiply top and bottom by the square root of 5 wherever it's necessary. So it's necessary for sine, in which case we're going to get -2 radical 5 over 5. It's also necessary for cosine because it has a square root of 5 in the denominator. So we'll multiply by square root of 5 top and bottom there. And then we'll get a square root of 5 over 5. It's not necessary for tangent, and it's not necessary for any of the other 3 because cosecant has denominator of 2, secant has denominator of 1, and cotangent has denominator of 2. So those are all good. Is that okay? Any questions there? All right. So, sorry, was that a question? Or?
Yes, I actually have
Okay. Yeah.
So would we, so how we completed this problem with doing the radical 5 at the end, is that how we would do all the problems if it was in the denominator?
Yeah, so if you ever have a radical in the denominator, your final answer should multiply by something so that it gets rid of that radical. Yeah.
Okay, thank you.
Yeah, no problem. And let me just box my answers because I didn't do that for this problem. And just to clearly identify what the final result is. Okay. So let's move on to page 3 then. This is going to bring us to the unit circle. And for the unit circle, well, unit circle means that the radius is 1. Okay, so the radius is 1. So what we're seeing here is a circle that has radius 1. In fact, you can tell that from the origin, meaning from 0, 0 up out into this point, which is on the edge of the circle, that has coordinates 1, 0. That's because we went 1 in the x direction, 0 in the y direction. So that means that distance is 1. Okay, so now let's tie it back to what we learned about sine and cosine specifically. Cosine, according to this alternative way of thinking about the trig functions, is x over r, right? Where x is the x coordinate of the point and r is the distance from the origin to the end of the terminal side. Well, if the terminal side, let's say that we're considering the terminal side for an angle that measures 30 degrees. So that one there. And here is our initial side always on the positive x-axis, right? So let's say that I'm considering this terminal side. What is this distance? If this is a unit circle. What did we say was the distance here?
1.
Is it 1?
Yeah, good, it's 1. So if the distance here is 1, and this is a circle, well, from the origin to any part of the edge of the circle, it's going to be 1. So r is going to be 1 regardless of what point you pick on the edge, right? Because the radius is 1. So what that means then is that cosine of angle theta is x on the unit circle. Okay, so it's exactly the x coordinate on the unit circle. Similarly for sine, if we take a look at sine of theta, by the definition that we just saw, it's y over r, but now the radius is 1, so that means that we get a y over 1. Or in other words, sine of theta is always the y coordinate of that point. So looking at this point, if I have x and y coordinates for it, the x coordinate will be cosine theta, will correspond to cosine, and actually theta here has a specific value, it's 30 degrees. So let me replace that in. Okay, it would be cosine of 30 degrees for the x, sine of 30 degrees for the y. Okay. And, well, we actually know how to find sine of 30 and cosine of 30. Okay, in fact, what we're going to do here is we're going to remember what those values are, as well as what are the sine and cosine of 45 and sine and cosine of 60. Okay, so if you have a sticky note, just go ahead and bring it out, or a scratch sheet of paper, so that we can have this handy somewhere on the side. I'm going to draw a 30, 60, 90. Yeah, so let's see, I'm going to draw the bottom angle as my 30, and then this top angle as my 60. So 30, 60, and 90. Now to 30, 60, 90, the opposite side to 30 is always the smallest side, which we call x. The side opposite to 60 we call x radical 3, and the hypotenuse is always 2x. And twice the amount of the smaller side. So if I want to find out what is cosine of 30 degrees, and well, cosine of 30 will be the side that's adjacent. So adjacent would be x radical 3 over hypotenuse, which is 2x. And actually, let me write out the definition because I want to make sure that we all remember where this is coming from. This is coming from the definition, cosine is adjacent over hypotenuse. So the side that's adjacent to 30 is this x radical 3 over hypotenuse, which is 2x. Okay. What happens to the x's?
They cancel out.
They cancel out, right? They cancel out. So these are gone. We get square root of 3 over 2. So cosine of 30 for any triangle is going to be the square root of 3 over 2. Let's do the same for sine. Any questions here with cosine before I move on? Okay, let's take a look at sine. Sine is opposite over hypotenuse. Well, opposite to 30 is x. And actually, let me again write the definition. It's opposite over hypotenuse. Okay, opposite to 30 is x. Hypotenuse is 2x. And again, these x's are going to cancel out. So we're going to end up with a 1 over 2. So that means that sine of 30 degrees will be a 1/2. Okay, so let's refer back to unit circle now that we have these values. For 30 degrees, this point will have an x coordinate that's the same as cosine of 30 by what we found up here. And we just calculated cosine of 30. Cosine of 30 is going to be square root of 3 over 2. So this first coordinate is square root of 3 over 2. Excuse me.
I have a question.
Yeah.
For the cosine of beta, which is equals x over r, how did we determine that the answer was x over 1?
The reason why is because this circle has a radius of 1. So regardless of which terminal side we're considering, from the origin to a point on the edge of the circle, that distance is always going to be 1.
Okay.
So that's where it comes from. So any angle on a unit circle will have r equals 1.
Okay. And then one more question. The calculations that we're doing on the post-it, is that just like an example, or is that an actual, like, is that the 30 degrees that we're doing?
So this one is 30 degrees with what we're working here.
Okay.
It applies to any triangle that has that 30 degrees. So regardless of what the sides are, the cosine of 30 will always be square root of 3 over 2.
Okay.
Alrighty.
Thank you.
Okay, yeah, no problem. Okay, so then y, if cosine of 30 was radical 3 over 2, that's our x. And then sine is the y, so sine of 30 was 1/2, which means that this coordinate is going to be 1/2. And we can actually repeat that process for 45 degrees. So let me just erase this terminal side because now we're considering an angle that measures 45 degrees. So it opens that way. That's 45 degrees. And for that terminal side, this point, maybe right now we don't know what it is. It's just x comma y. And I'll actually leave myself a little bit more room because eventually we're going to replace with numeric values. Okay. And according to what we just saw here, the x will be cosine of the angle. So it'll be cosine of 45 degrees. And the y will be sine of the angle. So it'll be sine of 45 degrees.
Could you explain one more time why the x corresponds with cosine and the y with sine?
Yeah, so from page 2 at the top, when we were looking at the definitions or the formulas that we derived on page 1, we saw that sine was y over r and cosine was y over r, where r is the length of the terminal side, right, which we can also find in this way. But r is the length of the terminal side. Let me actually write that here. And just to show you from the diagram on page 1, I'm going to go ahead and flip this over. Yeah, but if you take a look at page 1, where we first defined R, we said R is going to be this hypotenuse, which is also the terminal side. So that terminal side on the unit circle, this measures one unit. Yeah. So if I take that and I rotate it so that this is my terminal side now, R is going to be 1 because the length of the terminal side is still 1. So in the definition, cosine theta is x over r. R gets replaced by 1 so that we end up with x over 1, and then x over 1 is just x. And so that's how we get cosine equals x.
So
Similar-
the terminal side will always be 1?
On the unit circle, yes.
Got it. Thank you.
Yeah, no problem. Okay. So for 45 degrees, this diagram that we have here doesn't help us too much, or doesn't help us at all, because we have 30, 60, and 90. I'm going to go ahead and draw a diagram that has a 45, 45, 90 instead, so that we can calculate what are sine and cosine. So let's just draw a 45, 45, 90 triangle. Do you guys remember what was the formula for 45, 45, 90? A triangle that looks like 45, 45, 90? What are the measure of the legs?
The X goes on the short side.
Yeah, so X is for both legs because they measure the same, right? This is an isosceles triangle when you have a 45, 45, 90. The hypotenuse, do you guys remember what it was?
Was it radical 2?
Yeah, it was x radical 2. Very good. Yep, x radical 2. So if this measures 5, this also has to measure 5, and the hypotenuse would measure 5 radical 2. Okay. So based on this, if we now try to find what is cosine of 45 degrees, doesn't matter which one of these angles you consider, just pick one and stick with that one. So I'm going to pick the one down here. Okay. Cosine of 45 would be adjacent, which is x. And actually, let me write again the definition. So it's adjacent over hypotenuse. That would be x over x radical 2. And now x's cancel out. We end up with a 1 over radical 2. Now we don't like to have radicals in the denominator, so we want to rationalize that, which means I'm going to multiply top and bottom by a square root of 2. And the final outcome of this would be a square root of 2 over 2. Is this okay? Okay, what about sine of 45 degrees? Again, since we used this angle at the bottom for cosine, we'll also use it for sine. That is going to be opposite over hypotenuse. Opposite to 45, we have x. Hypotenuse will be x radical 2. So it's going to be the same thing, right? Same process. We're going to get 1 over radical 2. We're going to rationalize, and eventually we'll get a square root of 2 over 2. I just didn't write this down, but same thing. So now, now based on that, cosine of 45 is x. So that means that x here has to be radical 2 over 2, because that's what we calculated for cosine of 45. Just so we can erase the x and replace with the number. And y is sine of 45. Sine of 45 is radical 2 over 2. So y will have the same value as x, square root of 2 over 2. Okay, so questions there. All right, and then we'll take a look at 60 now. So we'll erase this terminal side because So now we want to look at an angle that measures 60. So meaning we're going to make it all the way to this terminal side. And again, this point, which at the moment we don't know what it is, x comma y, will be the same as cosine of 60 degrees, sine of 60 degrees. And even though we use this first sticky note to help us find cosine of 30 and sine of 30, I'm just going to use the same diagram to help me find out what the cosine of 60 and sine of 60 are now going to be. So cosine of 60 degrees is going to be adjacent over hypotenuse. Well, here's 60. Adjacent to 60 is x, so we would get x over hypotenuse, which is 2x. So x's cancel out, and we get a 1/2. Now for sine of 60, that would be opposite over hypotenuse. Opposite over hypotenuse is going to give us what? So what would the opposite side to 60 degrees be?
X radical 3
X.
over 2x.
Yeah, good. X radical 3 over 2x. X's will cancel, and we'll get a radical 3 over 2. Good. So now we can replace x and y with these values. X was cosine of 60, so here we're going to have a 1/2. And sine of 60 is y, so we're going to get a square root of 3 over 2 for y. Okay. Couple questions. Where did the x square root of 3 come from? And thank you, Martin, for answering that. Yes, that is a 30, 60, 90 rule triangle. And so this is just basically a formula that all triangles that have 30, 60, 90 angles will follow. Okay. Now to find the other points, we don't necessarily have to be drawing these triangles all the time. So for instance, for 120, I see that 120 has the same, is at the same height as this point of 60. They're at the same height. If they're at the same height, what is true about the what coordinate do they share in common?
A y.
Yeah, precisely the y. So if we were to write the coordinates for this, we would get that the y's are going to agree. We're going to get the square root of 2. Now for the x, well, the distance is the same as this distance for this point, but we're actually going in the negative direction, right? So what would be the x coordinate of this point?
Negative 1/2.
Negative 1/2. Excellent. Okay, so again, how did we get that point? Well, we first noticed that this point has the same height as this point. And height just means vertical distance, right? This vertical distance is square root of 3 over 2 from that point that we're reading. So that means that over here, this needs to have the same y coordinate. Then as far as the x coordinate from the y-axis out into that point, that is an x distance of 1/2, right? That's 1/2. We have that same distance, but going in the negative direction. So this needs to be negative 1/2. What can we say about the point at 135? What coordinates is that? Well, first of all, which point does it mirror? What does it reflect? What point on the first quadrant does it mirror?
Pi over 4.
Yeah, the 45, which is, or pi over 4, good. Okay, so it's mirroring that point there, which means they have the same height, right? And if they have the same height, what does that mean about the y-axis? About the y-coordinate?
They're the same.
They're the same. It has to be square root of 2 over 2. What about x?
It would be negative square root of 2 over 2.
Good. Negative square root of 2 over 2. Excellent. And one more point that we have here on the second quadrant. The point at 150 is reflecting the point at 30. So what coordinates does this point have?
2 over 1.
Well, not exactly 2 over 1 because we still maintain the same height. So it's still going to be whatever this height is. And this height is 1/2. So the y will still be 1/2. But the x will be what?
Negative radical 3 over 2.
Good. Negative radical 3 over 2. Excellent. Okay. So what are we doing here? We're taking these points, reflecting them across the y-axis, right? If you take let's see, I'll use that same string kind of demonstration that we did last time. If I take this string and I measure the distance to that point, that would be the x coordinate, which is 1/2. So up to there, that's 1/2. If I now take that and move it across the y-axis, that distance is also 1/2, but it's going in the, not 1/2, square root of 3 over 2. That's our x-axis. That's our x coordinate. So square root of 3 over 2. And then if I move that over, that's the same distance, but going in the negative direction. So I'm going to get a negative square root of 3 over 2 for x. If we think about the y, okay, what is the y? So the distance from the x-axis up to that y coordinate is 1/2. Well, I have that same distance from the x-axis up to that point of 1/2. So the y remains the same. It doesn't change. Is that okay? You guys have any questions? Okay, so we'll pause here, and then Monday's pre-recorded lecture is going to discuss how to find the points in the third and fourth quadrant, as well as what it means in relation to these angles. Okay, but in the meantime, thank you so much for being here. If you have any questions, I'll hang out for a couple more minutes. And then if not, have a wonderful weekend, and I'll see you next week.
Thank you.
Thank you, Professor.
Thank
Thanks,
you,
Professor.
guys.
Thank you.